Hi everybody, my name is Tim Bradrick and this is my demonstration for the accelerometer. What I did is I completed this in Unity, and here's the game. This is a very simple game to demonstrate the accelerometer. Right now you see the ball in the field and we're trying to move it over here to the white wall. You look down here in the corner, you see the accelerometer readings. We're going to click start and see if we can get that ball moving. Try that one more time. There we go. Now it's starting to move. It moves very slowly. This was a very simple game. As I tilt the device a little bit more, you see the ball move a little bit more rapidly, and then we're trying to get over there to the white wall, and then as I tilt it more, and then it touches it and we get a win condition. If we reset it, and then I will just tilt it in the opposite direction, got to get start going, tilt it in the opposite direction, and we will see a lose condition. And there we go. Thanks.
Hello, my name is Tim Bradrick, and this is my code demonstration for my accelerometer game for the Emerging Technologies class at Full Sail University. I completed that activity in Unity, and this is the scene that I created. In that scene, I had some very basic objects. I created the walls as cubes and set them up as colliders. And the glowing items is a particle generator. We have the sphere, and then attached to that sphere is a collider that was set up as a trigger. And then the other objects, which are the camera, the directional light, and so forth. Now, in the code is very, very simple. Attached to the walls, the lose colliders, is this code right here. If the sphere is passed into this function here on trigger enter, if the sphere enters the wall, these two Boolean values are set. Game one as false and the game completed is true. And then in a similar manner, the win wall is set up here, and that's where the game one is true. Now, the actual meat of the game is in the GUI script. Down here I have on GUI, and this is where I set up the variables for the buttons and so forth. This box right here displays the three coordinates: the X value, the Y value, and Z value. What I did is I rounded the numbers after I multiplied it by 10,000 and then divided it by 10,000 again to get back to the original number. That drops off everything after the fourth decimal place on those, so it looks a little bit smoother in the description. We have a start button. On start, the game starts, but the other two features are set to false. We have a reset button that sets all the values to false and sends the sphere back to the home position. That home position is the goal. I'm sorry, is not the goal. It is this value right here. It's a spawn location basically. It's just an empty game object that was placed so that we could reset the sphere back to that location. And then we have a win button and a lose button. And that's what you see at the very end in my demonstration video. To actually make the sphere move, what I did is right here, I set up a move vector, and very easy to read that information inside of Unity. I take the input class and the acceleration feature on that, and then X corresponds to the X value in Unity, and again I multiplied by 1,000 and then divide by 1,000 again after rounding to smooth it out a little bit. The tricky part here is the Z value corresponds to the Y value on the device. And then if the game has started, I take the move vector X and move vector Z and transform the sphere, basically translating it or moving the sphere, and then multiplying the move vector by time delta, so that if there's some lag on the display, it'll smooth out the motion of that. Thank you.